when we write code, we need to make certain that it works before we ship it out to the customer, right? We do not want our customer to find bugs. We want to find all the bugs before our customer ever sees them. So how to do that? Well, I have a bank account class here. The bank account has more than just getters and setters, right? So getters and setters are pretty much standard, but we have some custom methods called deposit and withdraw, and it has some logic in here to help people, put their money in their account or withdraw money from their account. There's also some logic for overdraft fees. So I'd like to figure out whether or not the logic that I've written for my class works the way that I expect it to. Now you could do this manually. You could go ahead into the main class and then create a bank account and then try to, manually test your application, see if it works. And that's fine, you should do that. But there are also other ways to do it in a more automated fashion, right? To basically click a button and have it run a bunch of tests and then say whether or not they passed or failed. That way knowing whether the logic of your application works. So to do that, we're going to do what's called a unit test, and we're going to use a library called JUnit. Now, I have a bank account class here. This code should be available to you as part of the lesson, so you don't have to necessarily type this all out. That'd be a lot of work. But go ahead and set up a public class bank account on your own system so that way you can follow along. And then I'm going to right-click inside an area where there's no code. I'm going to do generate and do test. All right. Now, you'll have JUnit here. You might have a fix button, okay, on the right. If you do, just click it so that way you can download JUnit, right? JUnit is a library that is in Java. It's very, very popular. You will probably use it at your work, and it is used to do unit testing, all right? So to do automated testing of your application. So I'm just going to hit OK. If you look over on the left-hand side where the folders are, you'll notice that there's a test folder, and now we have a bank account test class. All right, so your test folder will contain, no surprises, the tests for your application. There may be lots of tests over in this folder. All right, so now we've got, you'll see this import of JUnit at the top. If you did everything correctly, remember to hit that fix button. And then we have a bank account test class, which will have all the tests related to the bank account class. Now, let's start doing some tests. A test is just a method. You're just going to write a method and then write some code to test your different scenarios and see if they come out the way you expect. To let the computer know that, hey, this isn't just like a regular method I'm writing. This is actually an automated test I want you to run. We're going to use the @test annotation. Okay, so the @ symbol and test, and I just hit tab, so that way it would do the import up top for me, org.junit.jupyter.api.test. And now what we're going to do is we're just going to write the actual method. This method is going to be run, and we're going to, once I show you like what's in it, it'll make a little more sense. Public void, we're going to test return void, they don't return anything. And then we're going to call this deposit money succeeds. Now, as far as naming your test, that's up to you. You could name this aardvark for all the computer cares. The thing is, your test name should be descriptive of what you're testing for. Not just for other developers, but also for future you. When you come back and look at your test and try to figure out what, if a test failed, it would be really hard to figure out like what the test was about if you named it aardvark. All right. Now your company may have different standards as to how to name unit tests. May have no standards on how to name unit tests. That completely depends. So you'll just have to figure that out when you get to your job. But for here, what I'm going to do is I'm going to basically say action result. So what action is the user going to take, and then what is the expected result? All right, we're going to create a bank account. So inside this method, we're actually going to create a scenario. We're going to like instantiate classes and sort of set up our experiment. You can think of unit testing like a science experiment. You have a hypothesis. You then have a setup step where you basically get all your beakers and all your liquids and all your stuff that you're going to mix together, the Bunsen burner, and you put everything together, but you don't use it just yet. You get it all ready. Okay, then we're going to, so that's called the arrange step. All right, so it's the arrange step. After you arrange everything and you're ready to do your experiment, then you're actually going to do your experiment. That's called act. Okay, that's when you actually mix the chemicals together or heat the Bunsen burner or whatever it is that you're going to do to experiment. And then your hypothesis is the assert. Okay, what is your hypothesis? What do you expect to happen? Okay, what should happen? And then the unit test will tell you whether or not your assertion is true or false. Okay, did the experiment come out the way you expected, or did something else happen? All right, let's think about deposit, right? So we have this method called deposit. So essentially, my bank account has a balance that starts off at 0. And then if I deposit money, then it should take that amount and add it to the balance. So if I put $50 in to a new bank account, the balance should be $50. So let's go ahead and actually do that. We're going to create a bank account. Bank account equals new bank account. And then we're going to do bank account dot deposit 50, right? So this is going to be in the act section, right? So I created a bank account, which is why I need to run my experiment. Then I decided to do my experiment. I added $50 to the bank account. So now what I expect is that the bank account's balance should be 50, right? That's logical. We put 50 bucks in, it started off at 0, there should be $50 in there, not 100, not 200, just 50. To assert or say that, hey, I think that this should be true, we're going to actually just use JUnit. JUnit comes with what's called assertions. So we're going to assert equals, all right, and this is built in the JUnit. And if you notice, if you hover over it for a bit, you can basically take a look at like all the different overloads, all right? But essentially, assert equals is basically saying, hey, like I'd like to know, I give you two things. What number did you expect and what number did you actually get? So I expect 50. Okay, you can see that here, it says expected. I expect 50. And then what I got was bank account.getBalance. Right? So what I'm saying is if you do bank account.getBalance, you should get 50. If I don't get 50, then my test will fail. If I do get 50, then my test will succeed. So I'm going to hit this little green play button to run just a specific test. It'll start doing its thing. It'll compile. It'll build. All this is normal. All right, and I got a green check mark. Okay, it means that when I add money to my bank account, it is the balance that I expect. So deposit money works. It's just that easy, right? So like you're able to just use the @test. You create a method. It returns void. And then you give it a name, and then you create your test where you set up your test, you actually do the test, and then you assert, okay, what you think should be true after the test is done. All right, now let's move on. Let's actually create a test for withdrawal. All right, so now we're going to do @test, the annotation to say, hey, we're doing a test. Public void withdraw, no overdraft succeeds. All right, so essentially we're going to have a bank account. It will withdraw money that the bank account actually does have, and there should not be an overdraft fee. All right, so we're going to start off with a new bank account. And then we're going to start off with some money. So I'm going to deposit, and we know our deposit works, right? We've already tested it, so I know that this works because other test supports that assertion that it works. So I know that my bank account is going to have 100 bucks in it. And so now, as part of my act step, I'm going to withdraw some money from it. I'm going to withdraw $50, which is less than 100. So that means that there should not be any overdraft fee. All right, so now I'm going to assert a couple things. First, I'm going to assert equals that the balance of my bank account should be 50. Get balance, right? Because if I start off with, if I deposit 100 bucks and take out 50, I should have 50 left. I also want to make certain that I have this little Boolean here. Let's go up here, overdraft applied, to say whether or not the overdraft was applied, and I can actually get that. So I want to make sure that no overdraft was applied, so that Boolean tells me whether or not it was applied. So in this case, don't have to use this. I could use assert equals, but there's also assert false and assert true. All right, so we have a lot of these different kinds of asserts that are convenience methods. Okay, they're for our convenience. We could do everything. We could do a lot of things with assert equals, and it's fine. It's not like it's wrong, but this is a Boolean. It's either true or false. So it's nice to have a method called assert true or assert false that allows me to handle that scenario. So I'm going to do assert false, and I don't have to have two things. I'm going to have to have one thing. I'm basically saying something is false. So I'm saying bank account that is overdraft fee applied. It should be false. All right, let's run our test and see if that is true. Okay, we've got two assertions. All right, and your test can have as many assertions as it necessary to prove your case. All right, cool. So my test functions, my withdrawal account works as far as not applying an overdraft if there is no overdraft. All right, so we use assert equals and assert false. Okay, and this time our range step was a little more complicated. We have more steps here. But you get to decide how to structure your test, okay? So you have to think to yourself kind of like a before and after picture. In order to prove that code works, you need to think about if I set up the code in such a way and then I do something, I have an expected result. This is not random. This is a computer. It does what you tell it to do. All right, so now, let's say I wanted to run all my tests, that's pretty easy. Go up to where the line with the classes, and you can actually run all the tests in the bank account test class. And this is very convenient because as these tests are going to start to grow, you're going to get more and more and more of them as time goes on, and it'd be nice to just basically hit a button and run them all. Now, you're wondering, well, Jonathan, can't you just look at your code or just manually test this, and that would be fine? And that's true. The thing is, this is also kind of an early warning system. Let's say some other developer, like some junior developer, comes by in a month from now and just accidentally fat fingers the says the balance is 10, right? Let's say they just someone makes a mistake who's working for the company and they just accidentally put in some bad code. All right, now since we knew our tests were correct before, now when I run them, let's see what happens. Okay, you can do it up here. You could right click on this too and run them over in the lower left as well. And now I'm going to get these assertion fails, these like yellow X's. It's going to be like assertion failed error. And I'm going to be like, what? Because here I said if I start off with 0, I add 50, I should get 50. But now what it's saying to me here, if you look at it, if it fails, it will look red like this and then tell you what you expected and what it actually got. Right? If those things are not equal, then obviously your test fails. So now I'm thinking to myself, well, wait a second. Like, it's supposed to be 50. What happened? And so I can go back to my code and be like, oh yeah, some junior developer accidentally put a typo here. This should be 0. And then I can rerun my tests. Okay, oops. Rerun my tests. Okay, give it a second. And now they're all back again. So now I was able to correctly identify a bug, figure out where that bug is occurring, right? And then kind of hone in on it quickly. That's the power of unit tests. The power of unit tests is if you set them up correctly, they can be like an early warning system. When you make a change, did your change break some other code that you didn't even know about? Maybe it did, maybe it didn't. If you have enough good unit test coverage, you can figure out where your program went wrong. All right, these are pretty simple examples, okay, of how to use JUnit, but JUnit is great. It allows us to make automated tests, so that way as our program gets larger, we can test our logic without having to go through lots of manual testing. Now, we've got a different scenario here where I've got a string processor which allows to reverse words in a sentence. Right? So let's say we were testing this, and I've got a test. Test reverse words in sentence, and we have the phrase "hello world." And it's supposed to be "ole duro," right, when it is reversed. And so right now my test doesn't really pass. Okay, it's expecting to get this "ole dl row," except it gets "ole dl row" like this without the space in between. Now, the other cool thing about unit tests is it allows us to sort of figure out like, hey, where the heck is the problem? All right, because sometimes your code can have a lot of steps and a lot of ins and outs, and it's not clear where the problem is. But we can run our test in debug mode, and that way we can sort of step through it step by step. All right, so let's say I didn't know where the problem in here was. So I'm going to put a debug point, and notice how I'm clicking in this little like gray space in between the line number and then like this like line dividing line. So this allows you to put debug points on different lines. And the thing to remember about a debug point is that the code will run up until but not including the debug point. All right, so let's see what that actually looks like. I'm going to run my test in debug mode. So instead of doing the play button, I'm going to do the debug button. Right, so it will run the method and see how it stops. All right, so now the code is like sort of frozen in time. Right, so we've done everything up through line 6 or 7. Well, 7 is blank, but up through line 6. We have not actually executed line 8. But the cool thing about being in debug mode is you get to have sort of a really cool view of everything that you can do or everything that's going on, right, with the current code up until this point. The main event is this lower right-hand corner of the screen where we've got all the variables. So notice that these are the variables that are within scope currently, and we can literally see what their values are. So for example, we had the variable string sentence on line 4, and now we know that sentence equals hello world. Like you can literally like look at it, and if you want to go into the real nitty-gritty details, it gives them to you. All right, so far we took in a string called sentence. We created an array of string called words, and you can even see the array of string here. It's got a little like array thing, like that 0 index is hello, first index is world. I mean, reverse sentence is currently blank. Like you can see pretty much everything that's going on. From here, there's a couple things you can do. You can place multiple debug points. Let's say you were like, well, this is all well and good, but I want to go see here next. Right? So if you put a debug point and then you hit the continue button with this play button right here where you resume the program, it will continue doing all the code up until the next debug point. So now you've done some more code. We're now looking at the reversed word. Okay, the reversed word is ole, which is correct, right? And so we're like, okay, cool. We're kind of getting what's going on, but now we're like, okay, well, the first part's okay, So how about we continue with the program, but you're not necessarily sure where you want to stop. You have these three arrows here called step over, step into, and step out. They're right here next to the console, and they allow you to essentially control the flow of how you're doing it. So let's try step into. Okay, step into will actually say like, okay, are there any methods in here? Like there's an append method. You can actually dig into this method if you want to. We don't really want to do that. I think append's going to work fine. So we're going to step out for a moment, and then we're going to continue by doing step over. All right, so now you notice that we're still in the for loop. So now we're in the second part of the for loop. All right, so words had two parts. Now we've got hello and world. So right now, the word variable, right, let's take a look at it. Let's see if we can see it. So words is hello and world. So let's continue stepping over, right? And then we get all the way down here, it gets out of the for loop, right? And then you can see that like, hey, it gives us ole DLROW. So that means that we must not be, therefore, adding a space in between the individual words. So if you want to stop debug before it ends, you can just hit this stop button, all right? And that will stop the test, okay? And this allows you to like put debug points and step over and step into to sort of see like what's going on with the code while it's in flight. It's very difficult, especially with large amounts of code, to sometimes figure out which is the thing that's giving you a problem. So in this case, for example, like there's a for loop within a for loop. It might be very difficult to figure out which part is the culprit, but by doing it step by step and doing debug points and step over, step into, and using the lower right hand console to see the value of the variables, you can figure out what's going on. So let's see if we can fix this code. To do that, I think what I will try is we will check to see if we're at, so we were doing for loop. I think we may have to actually rewrite this a little bit. So I've refactored the code a bit because I'm going to need to figure out which word we're on, and I'm going to use J to kind of keep track of that rather than using the enhanced for loop. And I'm going to basically say, hey, if J is less than words.length -1, then we are going to reverse sentence dot append, and we're going to put a blank space here, so that way there's a space in between the two. All right, so after my investigation, I figured like, this might work. So I can just right click here. Oops, I didn't want to do that one. I want to see the difference. I want to run the test. It will build, and then there we go. Our test was able to pass. All right, so that debug stuff, that being able to put debug points, being able to run the test in debug mode, looking at the variables. So again, you can put a debug point down and you can run your test in debug mode if you'd like. You can even right click here and do debug. When you debug something, it will run the program up until the point it hits the debug point. It will show you all the variables that are currently in scope and their values. That way you're able to examine what the program looks like in flight. So the program is running right now. It's just basically stopped at line 8. It has not actually done line 8. It is stopped at line 8. So if you you can put multiple debug points down if you want to jump across them. You can just do resume program. All right. If you'd like to actually take a look at different parts of your program in more depth. If, for example, there's like a method that goes to another method, you can do step into. You also can do step over, okay, to sort of step over different sections. See how I'm just going through it, right? And then after you do all that, then you can keep going, right? So that, as you can see, this is a great way for to see your for loop or see loops like literally as they are running, so that you can see like how they are doing it. And at every point in this entire process, you can see the data in this lower right-hand screen. And if any time you would like to stop, all you gotta do is just hit the stop button, and you will stop the program in flight. Okay, being able to debug your tests is a core skill, and you will definitely need it when you become a developer. So give it some practice. All right, let's kind of switch gears here and learn more about what we can do with JUnit. So I've changed the scenario. We've got a product class, which is just a simple class with a name and a price. It's just any kind of product you can think of, maybe like a tennis racket or golf clubs, any sort of e-commerce type product. And then we have a shopping cart, which is just like a shopping cart you would find on a website where you could add products to your shopping cart, and it could tell you how much is the total cost of everything in the shopping cart. All right, so that's cool. We're going to test our shopping cart, and I've written some tests already. Test total price and test add product. So basically we're testing to make certain that like, hey, adding a product is working and getting the total price is working. So we added some products to our cart, and then we got the total price. And this is fine, right? So these are perfectly fine tests. The problem is that we're kind of repeating ourselves. if you look at the first 3 lines of code for each of these tests, then you'll notice that they're basically the same. We could consolidate this code into one place. That way we don't have to write this like 2 or 3 times. Again, not so much of a big deal for like 2 or 3 tests, but when these tests start, you're going to be writing a lot of tests for a project. So the more tests you do, the more typing you'll have to do. So we can consolidate code that's pretty much going to be boilerplate for all the tests, and we want to do that. And then we can use an annotation to help us do that. Right? So in order to not repeat ourselves, we're going to do at before each. Right? What this annotation does, it says, hey, run this method before each test. So every time there's a test, you're going to run the method. So we're going to do public void setup. Why did I call it setup? Because I felt like it. It could have been called aardvark or golf club or anything else that you would have felt like. All right, it's just the name of a method. It's nothing special. All right, I'm also going to take this code that we have that's the same, and I'm going to put it into the setup. I'm just going to break my code momentarily, but we'll fix it. And now I can write this once here, and these 2 other tests can use it, all right, because this setup method is going to run before these tests run. Now, you'll notice that, of course, now that the cart is out of scope, so what I need to do is I need to have a shopping cart, so private shopping cart, okay, that this can use. And we're going to change line 13 to this dot shopping cart. So this dot cart, okay, is equal to new shopping cart. I'm going to get rid of the spaces. All right, so now what we'll do is we'll initialize a shopping cart, add apples and bananas, and then run the test. Now my tests won't work immediately. If we run them, we're going to see something wacky happen. Okay. Oh, looks like they did. All right, awesome. So what you'll notice is in fact, let's put an S out here, S out, setup. That way we can kind of figure out what's going on here. All right, so I'm going to have it print out setup with a little exclamation point every time it runs. So let's run the test again. I don't need a debug point. Okay, see how I did it twice? All right, this way you can kind of visualize. When we ran this test total price, the setup ran first, then this test ran. Then we did test add product, then this setup ran first, then this test ran. So this code is always going to be run every time that we do a test. That way we don't have to rewrite this code. Every test inside of this file will basically do this setup first, and then all that code gets consolidated over here. Now, if you want to run something after a test is finished, and I think you've already figured it out, it's after each. So public void tear down. All right, so you can think about it this way: like you ran your test, you put the chemicals in the beaker, and then you did your thing, and then after that you were just like, okay, cool, we're done. We need to tear everything down, clean up all the beakers, clean up the table, put everything away. All right, so what you could do is the kind of stuff where you could like do any sort of like cleanup step. Like maybe you want to clear the cart out of things, or maybe you want to make certain everything's like cleared out. We're making sure the cart is like new every single time, but like let's say like you didn't do this, right? Let's say you wanted to like, I don't know, report on like the cart itself. So like we could do something sort of like let's do for product in this cart let's see, we need a getter for that. 1 second. All right, add a getter for it. So this cart.get products, and then maybe like s out like product.get name. All right, again, sometimes you might use teardown for like clearing stuff out. You might use it for logging. You might use it for any sort of little thing you need to do after the test is done. So let's kind of run our tests again and see what happens. Now, I've been using these arrows inside the test like window. You don't need to. If you go to the lower left and right click on the test itself, you could just go ahead and run it from there. That's way more convenient. You don't always have to do the same thing. All right, so set up apple banana orange. So now you can see that this is the teardown, right? So this is what's happening when teardown happens. All right, so now with these before each and after each, you can really control how your test is run, because like I said, these are pretty simple scenarios so far. In more complicated scenarios, it would really help to be able to consolidate all your code in a before each, so that you don't have to rewrite the code for each test. And maybe you have a cleanup step where you need to make certain that stuff is cleaned up or logged. in which case after each will run after each test. All right, so these are nice convenient annotations for us to use when doing unit tests. All right, we have the calculator class here, and I have a divide method, which takes two numbers, both doubles, and we'll divide them. And we have this nice little if statement that checks to see whether or not the denominator is 0. If the user gives us a 0 denominator, we're going to throw in a legal argument exception straight to their face and tell them they can't divide by 0. Now, if we think about this, my method actually is designed to throw an exception under certain circumstances. I am purposefully doing that. Normally exceptions just like pop up when like the user puts in some weird stuff, but in our case, we actually are planning to throw an exception if the user gives us a 0. We're not like waiting for the runtime exception, we're like electing ourselves to throw an exception, which as a programmer you can do. So that means then that this is expected behavior, and if it's expected behavior, we can test for it. All right, so I've created the calculator test class. I've got my test going, and let's go ahead and start writing it. Calculator equals new calculator. All right, cool. And then we can, here it's kind of difficult, right? Because I could do var result is equal to calculator dot divide 10 divided by 0. But the problem is that if I do this, then this test is going to basically fail, right? And I'm not really asserting that this equals anything, because result shouldn't be anything, right? Because if everything goes correctly, it should throw an exception, and obviously if it throws an exception, it's not going to return anything. So already I'm kind of having a bit of an issue here because this exception doesn't really fit into my standard pattern. So what we're going to do instead is that JUnit, the people who made JUnit knew that this was going to happen, and they have an assertion specifically to handle exceptions. It's called assertThrows. Oops, assertThrows. There we go. AssertThrows says, hey, I'm actually asserting that if I do my method, it will throw an exception. Like I'm expecting it to throw an exception. All right, so let's work through this. There's two arguments. The first argument is what kind of exception do you specifically expect for the method to throw? Well, if we look at my if statement, I want to throw an illegal argument exception. Okay, so that means that's what I'm expecting. Illegal argument exception dot class. Okay, so that's the first argument to assert throws. Like that's what I'm expecting. Okay, cool. The second part is we actually have to pass in what's called a lambda, an arrow function. We're passing in a function that this function is going to later call. If that doesn't make sense, it doesn't really need to right now. Okay, functions calling other functions, right, is a much higher level technique, but we can, just do the syntax and make it work. So here it's called a lambda. You have a parentheses, you have an arrow with a single dash, and then you have curly braces. Inside the curly braces, we're going to actually run our method, calculator.divide 10 divided by 0. Semicolon. All right, so inside of the lambda, we have these curly braces, and this is what we're going to run. Okay, so what we're basically saying is, hey, if I run this method, it should throw this exception specifically. And if it does, the test will pass. If it doesn't, the test will fail. So let's go ahead and run this. And there we go. The test passed. It threw an exception just like I knew that it would. All right, so as you can see, working with exceptions is a little bit different than working with just like values like we've been doing so far, but honestly, it's not that different. You just have to use assertThrows as opposed to assertEquals, and then you have to use this lambda in order to be able to sort of package the method you would like to run that's going to throw said exception. As long as you kind of remember this pattern, you should be able to handle this perfectly. What happens when we have to write a lot of tests against the same method? All right, I've got a password checker class, so you can imagine that this class is responsible for validating people's passwords when they come up with new passwords. And everyone's been in this situation. You have to make a password that follows certain rules. All right, so I've got this method. Again, this is probably not how you would really do this, but like it's good enough for our example. So my password must be 8 characters or over. So if it's less than 8 characters, then we're going to return false. It's not valid. And we're going to loop through the password, all the individual letters of the password, and check to see that, hey, does my password have a letter? Yes. Does it have a digit? Yes. So a valid password has to have both a letter and a digit and be 8 characters or more. right? So that is what this method checks for. And if you think about it, that's actually quite a few test cases because there's lots of different combinations of things that we have to test to make certain that, this thing works the way it should. So I've already gotten started on it. I've created a password checker test. So remember, you can right click, generate, hit test, right, and install JUnit, and so you can create a test. Now notice I've got validate password ABC123. I say, okay, here's my password ABC123. Okay, I expect it to be, in this case, actually false because it's only 6 characters. All right, so even though it has a letter and a number in it, it's less than 8 characters, so it should return false. All right, so let's go ahead and run that and see if that works. Cool. Okay, cool, that works. Now, if you think about it, I have a lot of different permutations here. All right, so for example, it's less than 8 characters. It should return false. But to be really thorough, I should check to make certain that even though it has like, a letter and a number, or a letter or a number, and less than 8, that it still fails, right? I should check those different combinations. And then even if it's 8 characters or above, it has either, a letter, a number, or both. So I actually have quite a few different tests that I'm going to have to write because there's different combinations of things I can imagine that I would have to make certain that I properly test for. So for example, I could write my next test, do @test void validate password underscore maybe like password 2024. All right, so you're kind of noticing something. I'm going to be writing a lot of tests. All right, and that's going to be a bummer because this test class is going to be really, really long and intimidating, and it's going to be a lot of typing. I'm going to spend a lot of my time typing test after test after test. Because if you think about it, I have to test for things like passwords below 8 characters. I have to test for passwords 8 characters or above with letters and numbers. I have to test for passwords 8 characters or above with just letters, with just numbers. Okay, so you see like the number of things I have to test is going to go up and up and up. So instead of doing it this way, because I'm always going to be using the same method, validate password, I'm not really changing the method. So for example, if I'm testing, let me go back to where we were, but like characters or above. Okay, with just letters. So I'll leave that back there. And what we'll do is, like, if you've noticed, when I'm writing these tests, they're not really that different from one another. Like, right, like password 2024. Like, how is this test really going to be different from this one? I'm going to make a string that will be the password. I'm going to say whether or not I expect it to be true or false. And then I'm going to make my assertion and just use validate password. So any test I write is just going to be a variation of this first test, if you actually think about it. So there's a much better way to actually do all this. So I'm going to go ahead and get rid of this. I'm going to get rid of my original test. And what we're going to do is we're going to parameterize the test. So we're going to parameterize the test. What the heck does that mean? We're going to provide parameters to the test that will serve as the different test cases. So instead of writing 6, 7, 8 tests, I'm actually going to write one test. And for each test, I'm going to provide it parameters. So first off, I'm going to go ahead and start with my method signatures. I'm going to do public void validate password. I'm going to add an annotation above this. All right. So we're going to actually, instead of just doing the regular @test annotation, which is the normal plain Jane, we're going to do parameterized test. Okay. So we're letting JUnit know I'm going to provide you parameters. I'm going to put arguments in here. All right. And I'm going to put 3 arguments. Actually 2, because we just need the password itself. So the password, and then whether or not I expect it to be valid. Okay, so I'm going to put 2 arguments in here. My mistake is 2. Okay, the password I would like to check, and whether or not I expect that password to be valid according to my rules. Well, the next question is, well, Jonathan, where is this data actually going to come from? Because you said that there's multiple test cases, and you're going to feed them into this method, okay, through these variables. Well, we have a way of doing that. We're going to use CSV source. CSV source will allow us to create data comma delimited like a CSV file. So if you're familiar with CSV files, they have data that's separated by commas, All right, and so we're going to do the same thing. We're going to create data separated by commas, and then we're going to feed that into the variable password and expected valid. So we're going to do curly braces here, and then all we're going to do is we're going to start writing our test cases. So first, the password is going to be ABC123, and comma, false. Okay, so you can see the variable password here is going to be given this data right here, ABC123. Okay, ABC123 will become the variable password. And then expected valid will be false. So I expect ABC123 to be false because it's less than 8 characters. All right, cool. Then I can do another one, comma, ABC1. That should also be false. Right, because it's less than 8 characters, but this time it's got, actually let's just do like with all letters, right, ABCD. Okay, that should also be false. Cool. So now I can just go ahead and write out everything I need. 1, 2, 3, 4. That should be false. Okay, it's less than 8 characters, despite the fact it's all numbers. Then I have password 2024. Cool. That should be true. Right? Because it's got letters, it's got numbers, and it's above 8 characters. All right. I can create another valid one. I can say another valid one. True. So now, instead of writing 8 tests, there's 5 tests, or however many tests we can do, then we can make more test cases. So I'll do lowercase only 1. That should return true. All right, so now, instead of writing a bunch of tests, what I'm going to do is I'm going to say, here are all the parameters. That's why it's called a parameterized test. We're going to feed parameters into the test. So now, I just use the variables like normal. All I have to do is basically, I can one-line this, assert equals, and then I can say, okay, cool. I expected valid is whether it's true or false, and then I will just do validate, password checker dot validate password and pass in the password. This seems a lot better to me, okay, in terms of space. I don't have to write 6 different unit tests. I just have to write 1 and feed these into it. So now when we run it, let's see what happens. As you can see, it looks just like normal, right? But it has parameters for the test, right? 1, ABC, 1, 2, 3, false. ABCD, false. So you see how each one of these lines up with each of the different test cases, and it runs all of them for me. So it's like I did 6 different unit tests, but only wrote 1. Okay, this is extremely efficient when you're just testing a single method with different parameters. All right, so to create a parameterized test, use the parameterized test annotation, all right, which is different than the regular test annotation. You provide the parameters with CSV source. Okay, each individual thing is a string, and then in it it's comma delimited like a CSV file. So you can have more than 2 things. I have 2 things, you can have 6 if that's what you felt like. Then you have your test, but instead of leaving this blank, we're going to actually put parameters in here, and they will be fed into by the data you provide inside CSV source. After that, write your test like normal, and you'll find that instead of writing like 10 tests, you only write 1 test, but with 1 test, you could actually test like 6, 7, 8 things. Okay, way more efficient using this method. All right, I've created this Pojo, this plain old Java object, and it's a person class. So it's got a name and an age, right? Nothing special, a constructor, and some getters and setters, which we've done a million times. So let's say I have a test, right? I'll make some space here. And I like to test if 2 objects are the same. So I've instantiated a person and person 2, and they're both named Bob, and they're both age 55. So what do you think is going to happen when I do assert equals person and person 2? Okay, what is JUnit going to evaluate this as? Because they have the same name, exactly the same name, and exactly the same age. So when I run this, let's see what happens. You'll find that the test fails. All right, why? Well, they're 2 different objects. So despite the fact that the interior of the object, meaning the name and the age, like its data, is exactly the same, the addresses of the objects, right, are different. Okay, this first one is 351D blah blah blah. This one's 77E4C blah blah blah. Right, they're different. And so because the memory addresses of both person and person 2 are different, then JUnit is going to basically say, yeah, no, they're not equal. All right, so how do we handle this? Because sometimes you might have 2 objects, right? And what you're really asking is, hey, are certain properties of these 2 objects the same? In which case, as far as I'm concerned, they are the same. Well, in order to do that, we're going to have to override how equals works. So basically how we evaluate the equality between these two objects. And that's not too difficult to do. So let's go over to the person class, and we're going to do a little addition. So after the getters and setters, I'm going to go down to the bottom, and I'm going to override equals. Do @override, which means essentially, hey, I'd like to do my own thing now. Like, we know that you're able to do the equals method. By the way, all things that are objects can have an equals method, but we're going to just do our own thing. Public boolean equals object obj. Okay. All right, this is the equals method, and we're overriding it. If something is an object, which the person class is definitely an object, person class, but basically if you didn't know this, all Java classes inherit from a parent class called object. So they're all objects. And so in which case we're going to say, normally it would check equality based on the memory location. But I don't want to do that. I want to do my own thing. So I'm going to override it and say, here's my way of checking to see if a person is equal to another person or another object. All right, so again, this object could be literally anything. It could be of the person class. It could be, like, let's say in the future we make other classes. It could be them. It could be a scanner. Any class in Java, right, that you make, right, and basically any other class, all derive from the object class. That is the top dog in Java. So first, I'm going to check to see, hey, is the object referencing itself? Is the object referencing itself? Because then it should be equal, right? A is equal to A, right? It's the identity. So we'll do if this equals obj, equals. Then we're going to say, okay, cool. We're going to return true. Awesome. If the object is itself, then yeah, it's the same thing. If the object is null, which objects could be null, or we can check to make certain that the object coming in is a different class. So for example, we have a person can't be equivalent to, I don't know, a shellfish, right? Like, or a scanner or any other class. So if the class, so we're going to get class of the object does not equal obj class, so obj.getClass, then what we'll do is return false. Now I know you're like, what the heck does this line 32 mean? Well, if the object that we're comparing person to is null, then obviously they're not equal because the other thing is null. But if the other thing is not a person class, so with this object.getClass, we'll get the class of whatever the other object we're comparing it to. Because object is the OG class for everything in Java, that means that object could be anything. It could be a scanner. It could be another class you made. So obviously, if we're comparing the person class to something that isn't the person class, then obviously that they're not going to be equal to each other. So we're just going to return false. All right, cool. So now we've got those out the way. So what we're going to do is we're going to downcast the object and say, okay, cool. Take that object and cast it to a person. All right, and once it's a person, then we can try to compare them. So when we say that one person is equal to another, what we're saying is that their names are the same and their ages are the same. Okay, that's what we're really saying. We're saying that these two people have the same name and the same age. So let's go ahead and do that. I'm going to return age is equal to person.age, and we can do name is equal to person.name. Okay, we can say that the two things are, if the two things are equal to each other, then we will claim that the two people are in fact the same. Let's go back and let's see if our implementation actually takes. Okay, there we go. Okay, now in this case, now it just goes and says, okay, cool. Your name's Bob and your name's Bob. You're 55 and you're 55. Therefore, these two people are the same. Now I'm going to switch one of these and let's see if that still holds. And there we go. All right, so now we are able to compare two objects. All right, and to be able to do that, we're going to have to override the equals method. And the equals method will take in an object. Remember that object is the parent class to all objects in Java. We say, hey, is the object we're comparing this to the same object? Well, then obviously they're the same because they're A equals A. hey, the object we're comparing this to is null. Well, then obviously they're not the same because this isn't null, so therefore that's not it. Hey, is the other object we're comparing this to not a person? Is it something else? Well, if it's something else, then obviously they're not the same. Return false. Okay? And then after that, we just check the name and the age of the person we're comparing this to, and then if they happen to be the same, then we will return true. If they're not the same, we will return false.